Here we're going to work with the abstract data type set, and sets are going to be an unordered collection. So our data structure might store them in some order, but from our perspective, we just care if the key is in there or not. And we're also going to look at iterators. Here's the Java API for that interface. And I want you to feel comfortable starting to use the Java API to look up what methods exist. So you can see it's an interface, which means it just has a list of methods that someone has to implement if they're going to implement that interface. And then it's parameterized. So we specify what type of thing our set will hold. And you can see some examples of implementing classes. And this slide just got really crowded, but here I have 5 examples of implementing classes. So tree set, hash set, concurrent skip list set, copy on write array set, and linked hash set. The details of those don't matter, but what I want to draw your attention to is that I can work with the methods that exist in a set, and I can call any of those on this variable mySet, and it doesn't matter which of the concrete classes I'm actually using, because here with mySet, I'm only going to call methods on it that exist in the set interface. So this is an example where the static type, that's the type of the reference, is different than the dynamic type, the type that I called the constructor. Sorry, the type of constructor I called, or really which constructor I called. So here the static type is set, and the dynamic type is one of these 5 things, but I interact with it in the same way. Here are the methods for set. Most importantly, I've got an add, an isEmpty, and then later on we'll look at iterator. Okay, so here's an example of using a tree set as the dynamic type and the set is the static type. And based upon line 22, we can see that there must be a toString method that works on a tree set. So you can see it starts off as empty, and then I add some letters to it. And again, with a set, it's an unordered collection from our perspective, and so we wouldn't rely on there being a set order that it gives us. Sorry, or a specific order. Okay, so I want you to pause here and try and trace through what the code does here. So you should pause and I'll keep going. So here we can see some of the basic functionality like isEmpty. Also seeing that contains is going to be case sensitive for strings. And that's because a capital A isn't equal or dot equals to a lowercase a. And on lines 18, 19, and 20, we try and add the element b 3 times, but that actually doesn't change the size because a set is just going to keep track of whether or not that item is in the set, and so it doesn't keep track of the idea of duplicates. So it's not going to add like a second copy of anything. Okay, next we're going to be looking at the abstract data type iterator, and this is going to allow us to iterate or walk through a set. And it has 2 methods. One is has next, so this is asking, is there a next thing to be able to try and access? And the other one is next, and people tend to find this one confusing. So it's like, imagine you are waiting in line, and then the person who's trying to serve you says, next! So next isn't an instance variable, next is like essentially a remove first in the thing that you're trying to iterate over. So here's the Java API for the iterator. It's got this has next, so it checks to see if there are more elements to iterate through. Next, which is going to return the next element in the iteration. And you can think about that as removing it from what will be iterated through in the future. Whereas remove is actually removing it from the underlying collection. Okay, so here's an example where I've created a set, all dogs. I add 4 dogs to it. Then line 51 is what's really important. Sets always have the method iterator that takes no arguments, and that's going to give us an iterator object back. And then on that we can say, we can call the method hasNext, and we can call the method next. And so my loop there is a super common one that we'll see with iterators. So we say iter.hasNext or while iter.hasNext, and then inside the body of the loop we say iter.next. That iterator functionality is actually what makes those for each loops work. So you can see the person p and then colon peeps. So that iterates through peeps. And you can think about an iterator as being underlying what's happening there. It's calling hasNext, and when there is a next, it calls next to get that next item. So here I want you to try and write code to use a hash set, and I've got the methods that you can call below, and I want you to print out the number of unique strings. So the strings in my array, I've got some duplicates in there, so I want you to use the hash set to count the number of unique strings. And you should assume that I would run it with something where you couldn't just like directly check if they were A, B, C, or D. Imagine you've got a million length string array. Okay, so you should pause it here and I'll keep going. So what I've got here is I'm iterating through my string array, and I'm using one of those for each loops. But I could have done it with explicit for int I equals 0, I is less than my array.length, I plus plus. I could have done that too. And inside what I'm doing is I'm adding each of the strings from this string array that I had and adding them to my set. And remember, a set doesn't keep track of duplicates. And so if I try and add something multiple times, I still just have the one item. So in the end, after I've added all of them, I can check the size of the set to get the number of unique strings in my string array. I want to bounce back to the list node homework and remind you, remember when we wrote contains for that? What was the requirement that we made of data type? So I want you to think about it, and you can pause and I'll keep going. So you can see on S, which is of type data type, we called the method compare to. And if we're calling the method compare to, that must mean that data type implements comparable. And this is just a big picture piece where sometimes our data set, our data structure that we're using, puts some requirements on the type of data it can contain. For example, if we're going to create a tree, we need to be able to see what is smaller or bigger than different things. And so those keys have to be comparable or implement comparable.